good morning my dear friends and students. I hope all are doing well and good. Welcome back to Ravi Math Space YouTube channel for math education. Myself B. Ravi. Today we are going to learn and discuss the topic 3 from real number chapter, that is revisiting rational and irrational number. Before going to discuss the topic, in the previous video I did one small mistake. First question, first problem, I did one mistake. That mistake you have to rectify. Once you see where I did mistakes means, this is the problem 140. This number we have to represent as a product of prime factors by using factor tree method. So 140 we can represent as a 2 into 70. After 70 I can represent as a 2 into 35. But here in the previous video I written here. How I written here? So 2 into 45 written. Please rectify this mistake. Actually here we should get here 35. We should get here 35. 2 times 35 is 70. Next 35, how I can represent here? 5 sevens. 5 sevens. So both are prime numbers. Stop the process. Therefore, answer 140 I can represent product of its prime factors means 2 into 2 into 5 into 7. This is the correct answer. It is for wrong answer. So sorry for the small mistake here I done. Please rectify that mistake. Okay, I hope understand the concept for this question. Okay, next today topic is revisiting rational and irrational number. What are the rational numbers? What are the irrational numbers? Can you tell me? Total we have how many numbers are there? Total we have uncountable numbers. We have uncountable numbers are there. These uncountable numbers are called as real numbers. Uncountable numbers are the real numbers. Okay. So these all numbers we can categorize as two types. First type is a rational number. Second type is a irrational number. Again, what is rational number? What is irrational number? Rational number means a number which can be expressed as P by Q. A number which can be expressed as P by Q, where P and Q are integers and Q naught is equal to 0. Such type of numbers are called as a rational numbers. Next one is irrational number. What is the meaning of irrational number? Exactly opposite to the rational numbers. Meaning is a number which cannot be represented in the form of P by Q. In the form of P by Q, where P and Q are integers, Q naught is equal to 0. Such type of numbers are called as irrational numbers. Means what we can conclude here? Real numbers are set of rational and irrational numbers. Rational and irrational numbers. What we can conclude here? Real numbers are either rational or irrational. Rational or irrational. This total combination is called as a real numbers. Again, what is rational numbers? A number which can be written as in the form of P by Q form. In the form of P by Q form, where P and Q are integers. One more condition is Q naught is equal to 0. Q naught is equal to 0. Such type of numbers are called as a rational numbers. Means examples are, what are the rational numbers examples here? Can you tell me? 1 by 2, minus 1 by 2, 3 by 4, 5 by 4, 1, 3, 2, 1.2, 1.3 and so on. These all are rational numbers. These all are rational numbers. Meaning is, actually we will get one doubt here. Sir, here 1, 3, 2 are not in the form of P by Q. How we can say it is a rational number? This number we can write as a P by Q form. How? See, 1 I can write as a 1 by 1 by placing denominator 1. By placing denominator 1, I can represent as a rational number form. That is the logic here. Meaning is, natural numbers are rational numbers. All natural numbers are rational numbers. All whole numbers are rational numbers. All integers are rational numbers. All fractions are rational numbers. Meaning is, this all are, we can represent in the form of P by Q form. That's why these are the rational numbers. Rational numbers. See here, these all are rational numbers. Any number which can be represented in the form of P by Q, such numbers are called as a rational numbers. Such numbers are called as a rational numbers. This is the condition. Now, what about irrational numbers here? Irrational numbers. The number which cannot be right in the form of P by Q form. In the form of P by Q form. Meaning is root 2, root 3, root 5, 5, 0.1011, 011, 0 and so on. Such type of numbers are called as irrational numbers. These numbers we can write in the form of P by Q form. Such numbers are called as irrational numbers. Such numbers are called as irrational numbers. Understand here concept. This is the revisiting rational and irrational numbers. So these all number types already I have explained very clearly and detailedly in the previous videos. You can watch that video, understand more better number concept. I will provide the link in the description box. I hope you are understanding the concept here. So rational and irrational. Simply very easy. The number which can be right in the form of P by Q form. Such numbers are called as rational numbers. The numbers which cannot be right in the form of P by Q, such type of numbers are called as irrational numbers. So what are the rational numbers? The combination of rational and irrational number is called as real numbers. Understand here. So both combination there means that is called as real numbers. Rational means P by Q form should be there. Then only this for rational. Irrational means which should not be in the form of P by Q. We can't write. Such type of numbers are called as what type of numbers? Irrational numbers. Okay. This is about as rational and irrational numbers. So real numbers, simply we can write the definition as a number which is either rational or irrational is called real numbers. Is called real numbers. So therefore real numbers equal to set of all types of numbers. Combination of rational and irrational number is called as real numbers. Now rational numbers, how we can write? Simply definition, a number that can be expressed as P by Q, where P and Q are integers and Q not is equal to 0 is called rational numbers is called rational numbers. Therefore, we can represent the rational number the letter capital Q is equal to some examples here. 3 by 5, 7 by 11, 2 I can write 2 by 1, 3 by 1. So 1.2 I can write as a 12 by 10. So all are the numbers which can be write in the form of P by Q. Such numbers are called as a rational. Now irrational number definition, how we can write in a simple manner. A number that cannot be expressed in the form of P by Q, where P comma Q are integers and Q not is equal to 0. Such type of numbers are called as a irrational numbers. Some examples here: irrational numbers: root 2, root 3, root 15, 11, pi. The name is called as a pi. I can read pi. So here it is non-terminating, non-recurring decimal number. So it is called as a rational numbers only. These are some examples of irrational numbers. It is non-terminating, non-recurring decimal number. It is called as a irrational numbers. These are the some examples of a irrational numbers. So if you want to take fatafat screenshot here. Yes. In this topic we have a one most important theorem is there. The theorem is, let P be a prime number and A be a positive integer. If P divides A square, then P divides A also. This is for very most important theorem. Every student you should remember this theorem and understand the theorem also. You should remember as well as you should understand the theorem. So I will explain very simple manner. Try to understand here. Okay. What is theorem here? Let P be a prime number and A be a positive integer. If P divides A square, then P divides A also. Now, how to prove this one? Yes, very simple manner we can prove. Let first given values in the statement. What is the given values here? Let P be a prime number and A be a positive integer. If P divides A square, then P divides A. First given values, right? Then we are going to prove that one. What are the given values here? Let P be a prime number. P be a prime number and A be a positive integer. What it is? A be a positive integer. Such that what it is? P divides A square. P divides A square. P divides A square. This is for given values. What we are going to prove here? We are going to prove P divides A also. That is to prove. So what is to prove here? P divides A. P divides A. Then proof. Yes. How to prove this one? How to prove here? See here. P be a prime number, A be a positive integer. Already we know. What we know? According to fundamental theorem, every positive integer can be expressed as a product of its prime factors. Product of its prime factors. Here A be a positive integer. This A I can write as a product of its prime factors. What are its prime factors are? I can consider P1 into P2 into P3 into and so on Pn. Here prime factors may be same prime factors, otherwise different prime factors. Otherwise, combination also will come. Understand it here. So, not same factor, not necessarily distinct factor. So, combination also will come. Sometimes same also will come. Whatever it will become here. Okay. So, P1, P2, P3. What are these? These are the prime members. These are the prime factors. So, P1, P2, P3 and so on. P and R. What are prime members? Or prime members. Primes. Okay. A positive integer. Every positive integer can be expressed as a product of its prime factors. Product of its prime factors by using fundamental theorem of arithmetic. By using fundamental theorem of, I am writing here, fundamental theorem of arithmetic. What is the meaning of FTA? Fundamental theorem of arithmetic. Understand? Okay. Next what? I want to order a square I want. Na? So here a came. Now a square. Then a square. So a square means how I can write here? P1 into P2 into P3 and so on Pn. It is for a value. Again multiply with the same means you will get the a square. A into a is nothing but a square. So same multiply. Again P1 into P2 into P3 and so on Pn. A into a, which is nothing but as a square. What you are going to get now here? A square is equal to, so first prime number same, like prime numbers or same prime numbers. We can multiply in the square form, right? So first prime number into first prime number square. Similarly second square, third one square and nth square. This is the a square. It is a square. Now what we should do? A square came. If I take one prime number, therefore now I am taking P is a prime number, divides a square. Divides a square. So one prime number I am taking, it divides a square. Can you tell me when it is divides? Conditions. If you want to divide P to a square means this P should be what? P should be one of the prime factor of a square as well as P is a one of prime factor of these factors. Understanding here? This is the condition. Then only this P divides a square. Otherwise no. Okay, write that one. So P should be how it is? This P divides a square means this P should be how it is? P is a one of factor of a square and P is a one of P1, P2 and so on Pn. Then only P divides a square, otherwise no. This, remember this condition here. P divides a square means P should be how it is? P is a one of the factor of a square as well as P is a one of P1, P2, P3. By using this, how I can write? By using, already here we written A is a product of its prime factor by using fundamental theorem of arithmetic. Meaning is a square is what here? A square is a prime factor of this one only. Yes or no? So this how I can write here concluding P divides A also. Why sir? Very simple. A is equal to, therefore A is equal to P1, P2, P3 and so on Pn. Yes or no? P also factor of A by using fundamental theorem of arithmetic. Hence if P divides P divides A square, then P divides A also. P divides A also. This is the proving the theorem. Hence, prove the theorem. Hence, prove. Understand? Very simple concept here. The positive integer, how we represented by using fundamental theorem of its product of its prime factor. Now, A is one positive integer. I can write as a square. A square is nothing but as a itself multiplication. So, here same multiplication, which is nothing but as a square came. Now, if I take one prime number, P divides A square means the P should be how it is. P is one of the factor of A square as well as P is one of these prime numbers. According to fundamental theorem of arithmetic, what we can say here, A square only prime factor of P1, P2, P3, only Pn only. So therefore I can write as a P divides A. P divides A. So therefore A is equal to P1, P2, P3 and so on Pn. So hence if P divides A square, then P divides A also. Hence the proof theorem. Understanding here? So this is the proof of theorem here. Understand here careful? Yes. Okay. Now if you not understand means through numbers I will explain, you can understand the better here. Okay. Same theorem I can explain as a numbers, you can better mode here. Okay. See how it is means, see here. Suppose if consider, so rub this one, I can rub this one, otherwise I will rub on this statement, I will explain clearly here. Okay, listen carefully. Suppose first one is what here, A be a positive integer. Let consider any positive integer. Suppose if I take positive integer 50. So 50. It is a positive integer. According to fundamental theorem of arithmetic, this positive integer, how I can represent product of its prime factor. So how I can write here 3 into 5. 3 into 5. Meaning is, how many factors we got here? It is for A, it is for P1, this is for P2. So A is a positive integer, I can express as a product of its prime factor. So let it is a 15, one is a prime number, so I can write as a 3 into 5. Next step is what here? A square, where P1, P2 what here? These are the prime numbers, yes or no? Yes, prime numbers only. Next, A square, meaning is, what it is? A square means 15 square is equal to, what is 15 square? 3 into 5 multiplied into 3 into 5. Yes or no? Which is nothing but as a 15 square is equal to 3 square into 5 square. It is for A square. Up to here came. Understanding? Next, now we should take one prime number. We should take one prime number. Suppose if I take one prime number, what prime number? 3. If I take 3 is a prime number. 3 divides, what is the number? A square means what is the number here? 15 square. 15 square. So 3 divides 15 square means, what are the conditions here? This P should be one of the prime factor of this A square. Yes or no? Already we know 3 is a factor, prime factor of 15 square, and as well as 3 is a one of 3 and 5. Yes or no? 3 is here, 3 will be there. 3 is one of this one, Now 3 is a prime factor of this one. Then what we are concluding here, this 3 divides 15 also, meaning is 3 divides 15 also. Yes or no? 3 divides 15. When it is 3 5s. This is the theorem. This is the theorem. So I hope you understand. Once I can see, let A be a positive integer, P be a prime number. Understanding here. So this A, how we are proving here? A I can write as a product of its prime factor 3 into 5. Now A square means I can write 3 square into 5 square. Now if I take 3 is a one number, prime number, if it is P value. P divides 15, A square. A square is nothing but as a, P divides A square is nothing but as a, meaning is what here? This 3 is a factor of 15 square as well as 3 is a 1 of 3 and 5. Then 3 divides 15. Yes or no? Directly you can say 3 divides 15. This is the proof of the theorem. Now understand the better. Understand here. So if you not understand, again once again watch the video, you can understand better here. I hope you all are understand the concept here clearly and perfect. Please do subscribe and share my channel to your friends. Until take care. Bye bye. Signing off.